I'll be back at the end of class.
Okay, great.
What time are you finished up?
Usually 8:45.
8:45? Okay,
Yeah. Or 8:40, 8:30.
Are you taking a break today?
Yeah, I have break.
2 breaks? What time's your first break?
Usually I take 2 breaks. One is around 6:50. 6:50. The other is 7:50.
6:50? Okay, I'll be back probably around then.
Okay. All right. Hello and welcome. How is everybody? Good. It's okay. Okay, make sure this is MATH1p97 section 7. We have 3 different sections. One is online, asynchronous. Professor Mark Willoughby is taking care of online. And the other is daytime, Tuesday, Thursday, and Friday. Professor Huda is taking that course. And this is Monday evening class, 6 to 9, okay? My name is Pauline Fu. I am your professor for this course. I hope you all have had a great winter break. Welcome back. And I also hope your course for this semester is a smooth and successful one. The agenda today, I will introduce myself. By the way, this PowerPoint slide is available on Brightspace. Go to Brightspace and course content. PowerPoint slide, you can find this one. And then we'll have icebreaker activity. Okay, so that you know somebody in this class. After that, we'll talk about expectations of students. Then I will introduce course outline, web assign. That is the learning platform where we do our online homework. That is 12%. We also have a CloudMark. You submit your written assignment on CloudMark. Okay. So today we do need to go over 2 chapters. Chapter 1 is the review for pre-calculus. Chapter 2, Session 2 and Session 3 for functions. Next week, we'll do Chapter 2.4 and 2.5. Okay. Any questions about the schedule, the agenda? All right. So go back to the first item, self-introduction. And this is my name. My official name, first name is Baolong. This is my official name, Baolong Fu. And I can be reached at tfu@blocku.ca. I have been teaching at Brock University for 10 years. I also teach at Toronto MU, formerly Ryerson University. Usually I teach business statistics, business forecast, multiple regressions. Besides my teaching, my research interest lies on online education. I want to see how do I draw students' inside power to forming learning community in online environment so that students are not feel isolated and students feel connected, forming a learning community. I'm also a proud author of 2 textbooks published by Course Technology. Yes, questions? Thank you. I try to move myself closer to the mic. My educational background includes an honors bachelor degree from Fudan University in Shanghai, China. I got my degree for business economics from York University. After that, I pursued my further study again at York University for mathematics and statistics. Finally, I got my PhD from University of Toronto. In my spare time, I like to walk my dog. She is just 1 year old. This is my second dog. I lost my first one. I like swimming. Brock swimming pool is fantastic, 50 meters long. I hope my teaching experiences and educational background will help you to learn this calculus course, okay? That's a self-introduction about myself. Any questions? Okay, you can ask questions throughout the lecture. Any questions? I just love your questions. I firmly believe that we learn fast, we learn deeply through asking questions. Okay, we are here to learn. So no questions are wrong or make nonsense. Every questions are great questions. Okay. So next, I will do some icebreaker activity. Okay, and I am going to so I will put you into the group. You form a group. Just turn the person, 3, 4, 5 students around you. Say your name among the group, your program, your hometown, and anything you want to learn, you hope to get out of the course. Any hobbies you want to share with us. And this will take about 6 minutes. Okay, go. Form a group, 6 minutes. And you can write down each other's contact information.
mic is not working. I don't know. It's like, it's not as loud. It's just really weird.
It is working.
Maybe, is this it?
You want to increase?
Like, to higher the... No, it doesn't work.
How do you know? This is to the... Hello?
Yeah, like, I can hear it, but I can't. I don't know if that makes sense.
Maybe this one. Audio. Maybe. I'll try this one.
Sorry, hon. Hello.
This one has to turn it on. Hello. Hello. Looks like, you see, this one is working.
Really?
See?
I don't know.
I have to close this mic.
Oh, maybe I'm hallucinating.
Thank you.
No,
I'll
thank
try
you.
to close, yeah. Okay, I hope you have a good discussion. Some students might have problem with the audio. Is it okay? Everyone can hear me? Okay, can you hear me?
Yes.
Thank you, I love that. Okay. So, hope you get to know somebody in this class by doing the icebreaker activity. Next, we talk about expectations. Students are expected to attend class, participate class, ask questions during the class. Allow your questions, okay? Any questions. Stop me at any time if you have any questions, comments, observations, okay? Students are expected to review the concept and techniques learned in class after class, okay? After class, if you have any questions, we have Mathematics Learning Center at the Department of Mathematics provide at least 6 hours a week. 6 hours a week, somebody is there to help you, okay? The help hours is available from week 2. Check out the website from Mathematics Department or go physically to Mathematics Department. Students expected to write the assignment, the test, exam. If you missed a term item, 0 is recorded unless you provide supporting document. Okay. The supporting document, the acceptable reasons for missed test and final exam are medical reasons, illness, religious observance. Okay. Okay, so those are the expectations. Any questions so far? Introduction to the course outline, web assign, and crowd work. So those items are posted on the Bright Space. So in the Bright Space, if you click the resources, The fourth item is course outline and syllabus. So we have 3 sessions. This is a Monday evening session with me. Okay. The course objective, this course we actually learn the application of calculus. So we are going to review the functions and apply methods of differentiation and integrations, formulate and solve differential equations, identify partial derivatives, solve calculate problems, use mathematical graphs to interpret the concept, and use computer software. Specifically, we are going to use GeoGL software to create some graphs. The textbook is applied calculus for managerial life and social science. You have to buy the textbook using the Brock University bookstore. Only through that way, when you buy the textbook, you will be given an access code to the WebAssign. We are going to use WebAssign for online assignments. We also use WebAssign for the term test final exam. Okay, so please go to campus bookstore to buy the textbook. The detailed instructions and the tutorials for WebAssign is here. Under the link, this is the WebAssign registration help. We need this one, okay? So make sure you buy the textbook through the campus bookstore. Okay. This is the tutorials, some useful information here. And during the lecture, I will do some demonstrations, okay? So that is the WebAssign, the software we are going to use. Another software we are going to use is free available on the website. It is geogebra.org/CAS. So we are also going to use this one. And again, in class, I will do live demonstrations for this website as well. Okay. This semester, we only use Brightspace. We do not use Sakai, so everything is posted on the Brightspace. Any questions so far? Okay. We have 5 written assignments, 25% total, so 5% for each written assignment. We have 4 assignments, each is 3%. 2 term tests will be decided by registrar's office at a later date and time. Test 1, 15%. Test 2, 20%. Final exam, 28%. Okay. So those are the major components in course outline. Regards to the assignments and test policy, I already stated, 0 is recorded if you don't submit assignment, if you miss the test, unless you provide supporting document, okay? And this course, we have actually course coordinator, Professor Mark Willoughby. Professor Mark Willoughby usually handle students missing the test, need to write the makeup test. You can directly contact Professor Mark Willoughby if you have to miss a test. Or you can contact me, but I have to forward your email to Professor Willoughby because he is responsible for all these 3 sections with regard to students missed the test or questions about missed assignment. Okay, so you decide want to directly, when you directly contact Professor Mark Willoughby, please clearly state your section. Our section is section 7, so that he is aware which section you are coming from. There are 3 sections, section 1, section 5, and section 7. We are in section 7, okay? So that is the course assignment, and the written assignment will be submitted to CloudMark. How many of you already used CloudMark before? Okay, terrific. Most of you use this one. How many of you know the GeoGebra? Okay, a few. If you don't know, go to this link. It will give you some tutorials. Go to this website, okay, to get some tutorials. Okay, and the textbook, you can click this link to get the access to campus bookstore. Okay, so this is the and PowerPoint slide for this is week 1, next week, week 2. So all the PowerPoint slides are here. All right, so that is the introduction about the course. Any questions? The structure of the lecture usually will take two breaks. One break is around 6:45, 6:50. The other break is around 7:45, 7:50. Each break is like 10 minutes to 15 minutes. Okay. Okay. Any questions? Great. So review. Chapter 1, pre-calculus review. Okay. Today we'll also go over chapter 2, just the first 3 sections. Section 1, section 2, section 3. Okay. Those are the examples of finite intervals. And you have the open interval, AB, using the round bracket. This is the open interval. Then you have closed, using the square bracket. You have half open, okay? You have left hand open, you have right hand open. So those are just notation because we use those a lot. Right? So if I give you, for example, -2 to 1, you need to know this refers to a set of real numbers from -2 to +1, not include -2, not include 1, but any number between -2 and 1. Okay, so that is the finite intervals. And we also have infinite intervals, means the number goes on and on. So this example from 2 to infinity means any number greater to 2. So any number greater to 2, okay, can be expressed in this way. And this number is any number greater equal to -1, any number greater equal to -1. So is this expression. And this one is any number smaller than 1, from -infinity to 1, any number smaller than 1. And this one, any number smaller equal to -1/2. So this is the infinite intervals. This infinite, we use this symbol. Any questions? Exponents and radicals. we just focus on the example. Make sure that you understand the example, okay? So this example, 2 raised to power 5, maybe it is too small. 2 raised to power 5 means 2 times 2 times 2 times 2 times 2. Okay, you have 5, 2. Anything raised to power 0 is 1. Okay, for example, -1 raised to power 1, that is 1. Anything raised to power negative number equal to 1 over a positive number. Okay, so for example, 2 raised to power -3 is the same as 1 over 2 raised to power positive number. Okay, and this is further equal to 1 over 8. So those are the exponents. And the other format of the exponent using the fraction. So for example, 16 raised to power 1 over 2. That is just the square root of 16. Okay. So 25 raised to power 1 over 2. This would be another example. Square root of 25. It is the same as 5. And sometimes if you have this format, 8 raised to power 2 over 3, 8 raised to power 2 over 3, that means it is a root of 3 and 2 is the power. So another example would be maybe 9 raised to power 3 over 2. What would be this number be? 9 raised to power 3 over 2. So this would be, anyone want to try? 9 raised to power 3 and then square root. Okay. And this would be square root. You figure out what is it. So this equal to this. So that is some exponents and radicals. There are some laws or rules for exponents. If you have x raised to power 2 times x raised to power 3, so the base x remain the same. You add the exponent part. Another example would be a raised to power 3 times a raised to power 5. So this would be a raised to power 8. Okay. Next one, you can check out this example, but I want to give you another example. B raised to power 5 over b raised to power 2. It is the same as b raised to power 5 minus 2 equal to 3. Okay. And then you have c raised to power 2, then bracket raised to power 4 equal to c raised to power 8, 2 times 8. And if you have a over b raised to power 4 equal to a raised to power 4 over b raised to power 4. These are some rules. I provided additional example in addition to this example. Any questions? All right. So these are the product formulas. Okay, everyone should know. a plus b squared equal to a squared plus 2ab plus b squared. There's an example here, but I would provide additional example. Okay, so I would say 3a plus 4b squared equal to 3a squared plus 2 times 3a times 4b plus 4b squared. So this is additional example. You can look over this example. Okay. And then expand. It is 9a squared plus 24ab plus 16b squared. Okay. All right, so now I will give you another example similar to this one. So I will say sin 3x minus a bracket times 3x plus a. And this one looks like this formula, so we apply to this formula. So equal to 3x bracket square minus a square equal to 9x square minus a square. Any questions? Factorial. So again, I will give you another example similar to this one. Okay, this one you can look by yourself. So another example would be a squared minus 81, a squared minus 81 to factor this one. So we know 81 is 9 squared. And then you apply this formula here, x squared minus y squared equal to x plus y, x minus y. So this one becomes a plus 9 times a minus 9. Okay. Another example, I will give you some examples similar to this one. Okay. Say y squared so y squared plus 12y plus 36 and we know 36 is 6 squared. And then we apply this formula here. Perfect square trinomial. And this 12, so it is just y plus 6, y plus 6 squared. That's it. Okay, next, I will give you example similar to this one. So I will say a cubed plus 64, factor this one. And we know 64 is 6, is a Uh, 64 is 4 raised to power 3. That's right. 4 raised to power 3 equal to 64. And then we use this formula, sum of 2 cubes use this formula, you get a plus 4 times a squared minus 4a plus 16. And this just need more practice. For example, when you go home, you go over this one, because this one I didn't go through. You go over this one. This one looks like this one. Use this formula, difference of 2 cubes. Okay. Any questions? Okay, quadratic formula, very famous, very important formula in quadratic functions. What is a quadratic equation? If any equation in this format, ax squared plus bx plus c, that is the quadratic equations. And for this equation, we have a formula for the solutions. So this is the formula for solution, x equal to this one. And there is a condition in using this formula. It is suppose b squared minus 4ac greater or equal to 0. Otherwise, there is no real solution in real number. Okay, let's take a look at example here. Simplify the following expressions. Item A. To simplify this equation, this expression, we usually use the factor. So x squared plus 2x minus 3. And how do we know it is equal to x plus 3, x minus 1? There is a method. I'm not sure if you learned this method in high school or not. So you take a coefficient of x squared. What is the number in front of x squared? It is actually has 1. The coefficient is 1. X squared is the same as 1 times x squared. And then you take the last number. This is -3. Okay. And now focus on -3 and this number 1. So number 1 is the result of which two products? So 1 times 1, the result is 1. Okay, usually we take the whole number. And this -3, which two numbers times together equal to -3? Can anyone give us some answer? Two numbers times together, whole number, the result is -3, yes? 3 and -1, excellent. What is the other way? Two numbers times together equal to -3. Do we have other options? Yes.
The inverse of both of those, -3 and +1.
Excellent. -3, +1. If you take -3 times 1, the result is -3. Okay? So we have two options. After you arrange data in this format, you use cross multiplication. So these two numbers times together plus these two numbers times together. If the result of these two numbers times together, so 1 times -1 plus 1 times 3, the result is what? Is 2. Did you see 1 times -1 plus 1 times 3? The result is 2. Okay? Now look at this picture. 1 times 1 plus 1 times -3. 1 plus 1 times 1 times -3. The result is -2. Which one is correct? I said this one is correct, this one is wrong. The reason is these two match the coefficient of x. So what is the number in front of x? It is 2. That's why this option is correct. When this option is correct, you just add x here, add x here. So the result is see 1 plus 3x. Oh no, x, not x here. So you just put x here. So the result is 1x. 1x is the same as x plus 3 times 1x minus 1, x minus 1. Did you see this? Okay, how do you work out this way? So this one won't work. But if I give you another expression as x squared minus 2x minus 3, I ask you to factor this. This one is correct. This one becomes correct. Okay, so the result should be x minus 3 times x plus 1. See, x minus 3, x plus 1. Okay, any questions? Okay, now let's take a look at the bottom part. X squared plus 4x plus 3. How do I know this one equal to x plus 3, x plus 1? I don't know at first. But now I have techniques. I want to put what is the number in front of x squared? It is 1. So I know 1 times 1 equal to 1. And 3, there's only option. 3 times 1 equal to 3. And you add x. So the result would be x plus 3. So x plus 3 times x plus 1. Okay. So I will put this way. So if you do cross multiplication, so 1 times 1 plus 1 times 3 equal to 4. This 4 is exactly the coefficient of x. Coefficient. Any questions? All right, so we just solved this item A, okay? Now let's do item B. Item B. So it is asked us to simplify the expression. So on the top we have x plus 1, x squared plus 1, x squared plus 1. This is the common factor. So we factor this out. On the top we have x squared plus 1. Okay, and then I take 1 x squared plus 1 because this is a square here. So I have another one here. And then I have -2. This is the first item. Now the second part, this part, after I take x squared plus 1 out, what is left is 2x times 2 times 2x. This is what is left. Okay, any questions so far? And I copy down the bottom part. Okay. And now I continue. Both the top and the bottom has x squared plus 1. So cancelled out. This one just have 3. When I cancel 1, this one becomes 3. Okay. So on the bottom, I have x squared plus 1 raised to power 3. On the top, if I expand this part, I got -2x squared, -2. Then I expand this part, I got 8x squared. You followed me? Any questions? And now continue, collect like terms, -2, +8. it is positive 6x squared minus 2. On the bottom, you have this one. Okay, so this is the final result. Okay, we cannot further, if you want to simplify further, maybe you can take 2 out, put it this form. Questions? Yes.
Say you have this question on the side, I think we can go further to fulfill. So I want to simplify that part.
Good question. If this is your final assignment, how do I know I end up with this part or I end up with this part? Is that your question? Usually you end up with this one. If you end up with this one, I usually ask my TA to mark your assignment genuinely. Okay, so don't worry too much. Other questions? All right. So rational expressions. This one is about operation on polynomials. Operation on polynomials. So let's go through this example here. So basically, if you have this format, P over Q times R over S, you just multiply top by top. So P times R, then bottom by bottom, Q times S. That's it. So for this one, the top is 2x, multiply the top x plus 1 as new top. The bottom is y, another bottom is y minus 1, and then you expand both top and the bottom. Okay. So any questions? And this one, the division for polynomial, if P over Q divided by R over S, you flip R over S, so it becomes S over R, and then change to multiplication. So for example, if I have A squared plus 1 over B divided by B cubed minus 1 over A, if I have this one. So first step, keep the first one. First, change this division to multiplication. And then flip top and bottom for the second part. The bottom becomes top. The top becomes bottom. So change the division, divide into multiplication. And then you use top times top, bottom times bottom. Okay, so those are the rational expressions for multiplication, division, and for addition. If you have the same denominator, you keep the denominator, just add the numerator part. And this is example. So just keep x plus 2, add the top part. Again, if you have my subtraction, you keep the bottom part, just do subtraction for the top, 3y minus y. This is just review, okay, from your high school, maybe grade 7, grade 8. Any questions? All right, shall we take a break? Come back at 7 o'clock, we'll continue the last part of chapter 1, inequalities, okay? Yes,
What was the answer for? I'm so sorry.
no problem.
I don't know where I went. Oh, there we go. Hold on. For question B, what was the answer to it? It was the.
Oh, question B. Do you have slide number 11?
Number
11.
Yes.
Slide 11. Yeah.
So I'm just gonna.
Yeah, go ahead.
So much. 2 minus 1 x squared. Okay, so I can just try it at home. Amazing. Thank you so much.
You're welcome. Thanks for asking. If you want, I can talk on the everyone can ask. Yeah, the only problem, sometimes the technology has a problem. So most often we have last answer, I have one letter, have problem. So one letter you Thank you for Initially, this is the 4. So this one transfer with this one, this one is 10.
This and this.
Yeah.
And then you got copy.
Yeah. And this one is 4.
Because it's a common.
Yeah. How much price?
Don't worry, I'm just talking. No, you are.
How many go from this equation here to the equals now? I know how to do it when it's just one coefficient in front of it, but how would you do it when
This 4 is 2 times 2. This is 1. 1 y squared. So 1 is could be negative 1 times negative 1 is 2. Right?
So you would still, because the way I learned it was that I learned the circles method. It's almost like the way that you taught when you do like the arrows.
Yeah, the arrows. Yeah.
So you can still do that, right? Even if it has a
Yeah. You can
Okay.
still do it because this is 2x minus 1 times 2x
Okay.
minus 1.
Yeah, because I would go like this and put 4x squared up here, and then put negative 4x minus 4x squared. And then 2x and 2x.
You can put 2x minus 1, 2x minus 1. Oh, this is if you have 1, this is 1.
Oh, right. This is from what?
No, you are correct. You have both x and y there.
Okay. Oh, so what would you do since you have
You do not think about this. You just 4 is 2 times 3. 1 is negative 1 times negative 1. Then when you cross multiply, they are equal to negative 4. That's it.
Okay, so you just look at this number and this number to equal this number.
Yeah, I will explain this
Okay.
on the board too.
Okay.
Okay, thank you for asking. That is a great question. Okay, everyone, shall we continue? Hello, everyone. Shall we continue? Thank you. So one great question during the break, how do I simplify this one? You have both x and y. You do the same way as we did before. You 2 times 2 equal to this 4. This is 1, negative 1 times negative 1 is this one here. Then you do cross multiplication. So 2 times negative 1 plus 2 times negative 1 equal to negative 4. Bingo with this one, negative 4. So this arrangement is correct. And then you just add x here, add y here. So the final result would be 2x minus 1 times 2x minus y. So it is the same as 2x minus y squared if you have two letters. Okay. Any questions? All right, so before the break, we did a review about the operations for polynomial, addition, subtraction, multiplication, and division. Now we move on to inequalities. There are some properties for inequalities. Some are very obvious. For example, if 2 smaller than 3, 3 smaller than 8, naturally we say 2 smaller than 8. Okay. If negative 5 smaller than negative 3, both sides we add number 2. The inequality still holds true. So negative 5, positive 2 is negative 3 smaller than negative 1 because negative 3 plus 2 is negative 1. Okay. This is property 1 and 2. Property 3 said if A smaller than B, if a number C greater than 0, so both this equation A smaller than B, you multiply by C. They are still hold true. So AC smaller than BC. This on condition C greater than 0. But how about if C smaller than 0? If C smaller than 0, and if A smaller than B, so A times C greater than B times C. If you times a negative number, it will change the direction. Before you have A smaller than B, because you multiply this inequality by a negative number, the result changed to greater than. So again, those are just review from high school knowledge, actually. Everything we did here, the first part is review high school knowledge. And this one is about absolute value, okay? Just remember absolute value, the result of absolute value is always a positive number, okay? So for example, -2 absolute value, that is 2. And 0 absolute value is 0. +3 absolute value is 3. 4 plus -5 absolute value equal to absolute value -1 equal to 1. Any questions? Okay, Cartesian coordinate system. A point in Cartesian system usually you use x, y. Okay, x is here, y is here. Any point on Cartesian coordinate system could be in one of the 4 quarters, and we call this part quadrant 1. When you have quadrant 1, x is positive, y is positive. And this is quadrant 2. X is negative, y is positive. Quadrant 3, x is negative, y is negative. Quadrant 4, x is positive, y is negative. Again, this is just review, okay? Nothing new. High school knowledge. The distance between 2 points, so if I have point x1, if I have point P1 is x1, y1, and another point I have P2, x2, y2. What is the distance between P1 and P2? This is the formula, distance equal to x2 minus x1 square plus y2 minus y1 square, take square root. Okay, why this is true? Because of the Pythagorean theorem. So if you draw a line parallel to x, draw another line parallel to y, you have right triangle. So what you need to do to figure out this length. So Pythagorean theorem said it is equal to this square plus this square, take square root. Remember Pythagorean theorem said if this is right triangle, and if this is x, this is y, this is z, for example. So z square equal to x square plus y square, or z equal to square root of x square plus y square, Pythagorean theorem. Okay, so this formula is based on this one. And this one is for the equation of the circle. with center. So if you have a circle, center is C, HK, radius is R. Okay. And what is the equation for this circle? It is x minus h plus square plus y minus k square equal to r square. Why this is true? Again, Pythagorean theorem. Okay. So if you draw a line here, draw another line here, so that this is the right triangle. So based on Pythagorean theorem, you have this relation. Okay. All right, so now let's look at an example. I'll give you a few moments to read over the questions. So basically, this question you have for S. S is here. See, this is your S. Okay. And this is the point M. This is M. If the cost of running a cable on the land is $3 per running foot, and the cost of running cable underwater is $5, find the total cost for laying the cable. So what we are going to do, so what is the question here? The question asks you, you try to laying the cable from here to here, and then from here to here. So what is the cost laying a cable? The red line represents the cable. And this part is underwater. When the cable is underwater, it is $5. The unit cost is $5. And this part is on the land. When the cable is on the land, the cost is $3 per unit. The question asks you, what is the total cost for the cable? Okay, so the total cost has two parts. One is the cost for the land, the cable on the land. The other is the cost, the cable underwater. Which one represents the cable on the land? This part here, from here to here, is cable on the land. Okay. How long this one is? So this point position is 10,000. This S, the point Q is 2,000. So what is the distance between Q and S? Anyone? What is the distance between Q and S? Yes. 8,000? Excellent. Anyone get this? The distance between Q and S is 8,000. That is the length on the land, right? So 1 unit cost for the land is $3. So the cost for the cable on the land is 3 times 8,000, right? 3 times 8,000. Now let's take a look at this part. This is the cable underwater. When cable underwater, the cost is $5. And now we need to know what is the distance between M and Q. What is the distance between M and Q? Any idea? How do we find distance between M and Q? Yes. Use 3,000. And then what? 2,000, take square root, Pythagorean theorem. So basically, when you look at the triangle MOQ, look at this triangle. The distance between O and Q is 2,000. The distance between O and M is 3,000. So what is this part? Pythagorean theorem. So this part is square root of 3,000 square plus 2,000 square. Did you get this? Okay, so this length is square root of 3,000 square plus 2,000 square. And then you times 5 because the cost is 5 per unit. Okay? So the total cost, I write down the equation here. 3 times 8,000. 8,000 is here. From here to here is 8,000 plus 5 times SQRT means square root. SQRT means square root. So that is the total cost. Okay. Make sure you know how to get this number. The final result is here. You can use Excel to quickly get that number. So what I try to do, I try to calculate what is 3 times 8,000 plus 5 times square root of 3,000 raised to power 2 plus 2,000 raised to power 2. What is the result of this number? In Excel, you just type in this expression, it will give you the result. Okay, so I will copy this formula and make it bigger. No, it will distort my, I'll copy it here and make it bigger. So in Excel, you just type in this one, you get the result. Okay, equal 3 times 8,000 plus 5 times square root. Any questions? All right, that concludes chapter 1 review. Okay. Now move on chapter 2. Chapter 2 is all about functions. Again, the beginning part might be the review, and we are going to use the strict mathematical definition about what is a function. A function, it is just a rule that assigns each element in set A and produce one and only one element in B. So for each element in A I only produce one element in B. That is the function. Okay, now listen up. Do you think the following statement will produce a function? Okay. In every element in A, I produce the two elements in B. Is this a function? Can this process produce a function? Yes or no? I repeat, for each element in A, I produce the two elements in B. Is this a function? No, why not? You are correct. Why not? Yeah, the definition said only one element in B, but I produce the two elements in B. And can you give me a picture? How come for element in A, I can produce two elements in B? Okay, this is the picture. If I have this graph, I have 1 point in element A in X. Now I produce 2 points here. For one element, I produce 2 points in B. This is not a function. Because for one element, I produce 2 points. This is not a function. Okay. So the definition of function is, for one element A, you only produce one element in B. So can you give me a graph? One element produced one. If I have this, if I have 1 point here, I only produce 1 point here. 1 point here, 1 point in A, I produce 1 point in B. This is an example of a function. For every element in A, I only produce one element in B, okay? So the notation for the function is f of x. We know this, we're familiar with this one, but maybe sometimes we don't know how to read this. It is f of x. Sometimes we just simply say fx. This read as fx. Okay, example. If fx equal to 2x squared minus x plus 1, find f1. Easy, right? You plug in x into 1, and you get final result. Okay. By the way, my PowerPoint slide sometimes just give you the question. So for this one, I give you just solution for A. I tend to leave B, C, D to solve in class. Okay, so you see, next one is a new example. This one don't have solution for B. So now we are going to do B, f negative 2. F negative 2 means you use negative 2 as x. When you see x, plug in negative 2. When you see x, plug negative 2. And then you simplify. So 2 times 4 plus 2 plus 1 equal to 11. Okay. So this is B. And what is C? C said, what is FA? FA means when you see X, plug it into A. So it is this one. This is FA. Instead of X, you say A. Any questions? Okay, last one, D. F A plus H. Whenever you see X, plug it in with A plus H. Whenever you see X, write down a plus h. Whenever you see x, it is a plus h. And then you simplify this expression. So this is a square. So a squared plus 2ah plus h squared minus bracket a plus h plus 1. Take away brackets, you have 4ah plus 2h squared minus a minus h plus 1. And collect like terms. So this is a 2a squared. There's no like term, right? This is the final result. There is no like term to collect. Yes, questions? Okay. Any questions? Okay, application. An open box is to be made from a rectangular piece of cardboard of 16-inch long. So this is 16-inch long and 10-inch wide. By cutting away identical squares, if you cut away those 4 squares, okay, these squares are x inch. And then you fold it up, it is a cardboard, an open box. Okay. Now what is the question? What is the question here? The question is, find an expression that gives the volume V of the box as a function of x. Okay, and then what is the domain of the function? So let's find the volume V. So this is an open box, it has volume. The formula for so we know from high school, the volume for this shape is area times height. Area, where is the area? This part. This part is the area on the bottom here. This bottom area times height. And the height is here, is x. X is height. Right? X is height. This height is x. And now what is the area here? This is rectangular, the area. Rectangular area equal to length times height. So what is this part? The whole length is 16. Then you cut x here, cut x here. So 16 minus 2x is here. Did you see this? 16 minus 2x. Why 2x? See, one x is here, another x is here. So you have this part is 16 minus 2x. Any questions? Okay, this is on one hand. On another hand, what is the height from here to here? It is 10 minus 2x because this part is 10. And you cut x here, cut x here. There are 2x, one x, another x. So from here to here, you have 10 minus 2x. Did you see 10 minus 2x? Any questions? Okay, so this area, what is this area? It is 16, it is actually 10 minus 2x times 16 minus 2x, this is the area, and then times height. The result is the volume. Area times height is the volume. Any questions? Okay, so now we just need to simplify this expression here. Okay, so area times height, x is height, and this area equal to length times width. So, okay, so you simplify this expression. And this is the fourth question. What is the expression? The second question, what is the domain of the function? The domain of the function must satisfy length greater than 0, width greater than 0, and height greater than 0. Okay, so from the first one, from this one, we get 16 greater equal to 2x, right? Both sides divided by 2, you got 8 greater equal to x. So x must be smaller equal to 8. And from here, 10 greater equal to 2x. So 5 greater equal to x. So x must be smaller equal to 5. And here, x greater equal to 0. Then you use the number line. So this is 0. If this is 0, x smaller equal to 8. So if this is 8, so it is here. Okay, smaller equal to 8. Here, x smaller equal to 5. So this is 5, smaller equal to 5. And here, x greater equal to 0. So x is here. So what would be the final answer? Anyone, based on this picture, what is the domain? What is the value x can allow to get? The final answer, anyone want to try? Yeah, x is from 0 to 5. You can write down this format, or you can write down this format. Okay, the final answer, x between 0 and 5. Questions? Yes. Okay, yeah.
My question is, so would we have to essentially just go from those 2 steps and then go from 16 divided by 2? Does that make any sense? Like, so when you equal to 160 minus 52x, do you get the 160 by, where do you get the 160 from?
Thank you. You expand these 2 brackets. So you use, let's do step by step. So 16 times 10. 16 times, do step by step, baby step, okay? 16 times 10 minus 2x minus 2x times 10 minus 2x. Forget this x, we just focus on these 2 brackets times together, okay? So, any question on this step? Okay, now 16 times 10 is 160 minus 32x minus 20x plus 4x squared. Simplify this one, 160, 160. Collect like term, negative 32, negative 20 is negative 52. And you have positive 4x squared here.
Okay.
Okay, Thank you for asking. Just expand this two bracket. So what is this bracket times this bracket? Multiplication of two expressions. Okay. Any other questions? All right. So piecewise functions. This function has two situations. Situation 1, if x smaller than 0, it is negative x. Situation 2, if x greater than 0, it is a square root of x. Okay. What is the question here? Sketch the graph of this function. Okay. So now I'm going to introduce, remember this course, we need this software, GeoGebra. Okay, write down this web address, https://geogebra.org/cas. So this function means when x equal to, this is x, this is y. When x smaller than 0, fx equal to negative x. So the negative x obviously is this one. Negative x, okay. So now I'm going to use this software. So I will go to this website, okay. Can I just copy and paste? No. GEOGE. Oh, my battery. Give me 1 second. GEOGE. geogebra.org/cas. This is the website. If you have computer, I encourage you to go to this website, follow my steps to go to this website. So after that, we want to produce a graph. Which graph? So we want to produce y equal to negative x, okay? So you just, in the input, you just type in y equal to negative x, y equal to negative x, and then you press Enter key, Enter key. See, you got this line. So this line represents y equal to negative x, okay? And then this is when x smaller than 0. So only this part here. Only this part when x smaller than 0. Don't look at here. This is x greater than 0. When x smaller than 0, it is just this part. And now another one is what happened when x is greater than 0. It is square root of x, square root of x. So you need to produce another line. So this is the input. You just type in y equal to SQRT, means square root. SQRT, bracket x, When you press bracket, it automatically gives you the square root sign. Okay, and then you press enter. So this, you see this line here, that is the square root of x. Okay, so the combination, the combination of this part and this part is the graph of that function. When x smaller than 0, this is a straight line. When x greater than 0, it is this green line. All right, so I just want to copy this so that copy. Okay, so sketch, it is here. This is the sketch. Any questions? And I'll give you the hint. Just typing y equal to x, y equal to sq, x here, input, you get the graph. Okay, next example. The value of x corresponding to x equal to, oh, sorry, I should use the mic. The values of fx corresponding to x equal to 0, 1, 2, 3, 4 are in this table. Use these values to sketch the graph of function. The graph of function. This time I want to use Excel to do it. Okay, I want to use Excel to do it. So in Excel, you type in 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4, 3, and then 4. Okay, that is your x. And let me see. And then you need the square root of this number. So fx is actually equal to square root of x. Take square root of x, that is your f. Take square root of x, that is your fx. So in Excel, it is SQRT. This time, I want to use cell reference. So our quick cell A1 represents 0. The reason is I want to copy down the formula using the fill handle. So each number, for example, 1.414, it is the square root of 2. 1.73 is the square root of 3. Okay. And now I can produce a graph. So select those data, go to Insert, Charts, All Charts, X, Y scatter, click this one. And this is, you join all these lines together. This is the sketch. Okay. Any questions? So this is in Excel. Okay. And now, how do I use GeoGebra to produce this graph? In GeoGebra, I give you the hint here. You type in bracket 0, space, bracket 1, space, bracket 2, etc. Enter. And then you type in y equal to x raised to power 1 over 2. Because y equal to square root of x is the same as x raised to power 1 over 2. Okay, so now I will demonstrate using GeoGebra. When you start a new demonstration, you can press enter on this website, then select reload. So it reset up. Now this is the input box. You type in bracket 0, space, bracket 1, space, bracket 2, etc. I type in every number put into the bracket, and between bracket you have space. After that, press enter key. And then next time you type in y equal to x square x raised to power 1 over 2. So y equal to maybe just SQRT. I'll try SQRT x. Okay. And then you press enter. See, you got this graph. Okay. So any questions? Okay. Shall we take our second break? After break, we do the vertical line test. Okay. So come back at 8 o'clock. Come back at 8 o'clock. If you don't mind, can I write down something here? Can you remind me which slide? 25. Okay. So 25. Remember this one represents length. Length must be greater or equal to 0. This one represents width. Width must be greater than 0. And this one represents height must be greater than 0. Okay. So now you need to solve 3 inequalities. Those are inequalities. Solve 3. Let's solve one by one. So first, this equality. You move this negative 2x to the right-hand side, becomes 16 greater or equal to 2x. Okay, and both sides divided by 2, you got 8 greater equal to 8.
Right. So it can be greater than or equal to 0. Like
This
the
one?
length could be 0 of the box.
Theoretically, it could, but if you say greater 0, that's still fine. Okay?
So that's saying x has to be less than or equal to 8.
Yeah. Okay, so this is the first inequality. Second inequality, you follow the same procedure. So 10 small greater equal to 2x. Both sides divided by 2, you got 5 greater equal to x. So x smaller equal to 5.
Right. Okay.
So x smaller equal to 5. So this one, x greater equal to 0. So there are 3 results. So x smaller equal to 8, x smaller equal to 5, x greater equal to 0. The common part is this one here, 0 to 5.
So from 5 to 8, it's kind of irrelevant because it has to be less than 5 anyways.
From 5 to 8, for example, 6. 6 violate this one here.
Okay. It has to
We must satisfy all 3.
Okay.
Okay?
So if there's 2 that are less than x, you just take the smaller one?
Yeah.
Okay.
Just make sure all the 3 conditions are satisfied.
Okay. And is this always greater than 0 because you wouldn't have a width that's less than 0? Or a length that's less than 0?
We don't have anything.
Like, would the first equation here always be greater than or equal to 0?
Yes.
Okay. And then you solve for it.
always
Yeah.
keep the equal to.
Yeah.
Okay.
Always length, height, greater equal to 0.
Okay.
Always.
And then you solve and then satisfy each 3, and that's your domain.
Yeah.
Okay.
Okay. Yeah.
Thank you.
Thank you for asking. Yeah. Hello.
Sorry about this. I was just going back over the example earlier
Yeah, yeah,
for the
I
first
know
grade.
that.
And doing the expansion, I was wondering, can you not with x squared plus 1 to the power of 4, is x squared plus 1 to the power of 2? Can you not just cancel this out? And put
Good
this as 2?
question. Good question, but you can't
You can't.
because we have this plus sign here.
Right, okay. So,
You just cancel 1, that's fine.
Yeah.
So there are 2 here.
yeah,
Cancel 1.
right. But you can't get rid of it entirely, otherwise it's just kind of
No,
messes us
if
up.
you want to get rid of entire, you have to take this x squared plus 1, take
Yeah.
this out, like I did this x plus 1 here,
Yeah.
take that out.
Mhm.
You cannot, okay, this 2, this 4.
Yeah.
This cancel, this has 2. No,
No.
because you have another one here.
Right, okay, gotcha. So then you can just, essentially if you have something like this in the future, you can expand it and just take out 1 to simplify a little bit like you did, right? Like
Yeah, you can take this away,
yeah,
just 1,
yeah,
so that this one comes a bracket.
okay,
That way you can cancel this one with the bottom part.
right, okay, so you just remove it from, okay, I get you. Okay, excellent, thank you very much.
You are welcome. Thank you for asking.
Thank you.
So, to determine if that was
There are 3 inequalities here. The first inequality produces x smaller than 8. The second inequality produces x smaller than 5. The third one x greater than 0. So out of these 3 results, which one is the common? We have to satisfy these 3 at the same time. So which one satisfies these 3 at the same time? Only 0 to 5. Only 0 to 5. Thank you for asking.
So let's see.
So this equation you have to remember was when you have 4x equation it's accurate, but you just feel like you're just the equation if you get full
So
the equation right there 4x
minus 52.
Yeah, graph 160. So what do you say?
You can hold it 4x with if you want to.
Oh, can you take x away? You know, factor.
Yeah, like I would just hold it 4x out and put brackets around.
But if you take 4x, if you take this 4x, oh, I mean, then you got x squared minus 13x plus 106. Is this what you mean?
Well, I thought couldn't you just, well, you can divide 160 by x as well.
Is that what you
Like,
mean?
I would have had it as 4x bracket, then it'd be x squared, then 13x. Then,
Yeah, this is x squared, negative 13x, then 160. Oh no,
Yeah,
then
it's
40,
divided
40,
160.
then 40, not 160, 40.
Right.
Yeah, you could
You
write
could do
down
that,
this.
but there's no point, right?
You could have this one. It's also correct.
Right, but it wouldn't matter. Like I wouldn't lose marks if I didn't simplify it.
Yeah, exactly. Thank you for asking. Remember, we have 3 inequality here, 3. We have to satisfy those 3 at the same time. So let's do one by one. The first one, we get 16 greater or equal to 2x. So 8 greater or equal to x, right? This is the first one. The second one, 10 greater than 2x. 5 greater or equal to x. This is second one. The third one is x greater than 0. So the first one, x smaller or equal to 8 is here. Maybe we draw the timeline. The first one, this is 0, this is 8, is here. So from infinity up to 8. The second one, x smaller than 5, this is 5. Okay, the third one, greater or equal to 0. Which part in this timeline can satisfy all these 3 conditions at the same time? You tell me which part to satisfy these three conditions at the same time. Only 0 to 5. So 0 to 5 satisfy x smaller equal to 8. 0 to 5 satisfy x smaller equal to 5. 0 to 5 satisfy x greater equal to 0. So 0 to 5 is the final answer. 0 to 5.
Are those 3 numbers the factored numbers of the formula?
Which 3 numbers?
Like those 3 sections, are those the factored sections of the formula? I thought
this has nothing to do with the factor. This has something to do with the range of the real number, which x are allowed to take. In this case, x can be taken from 0 to 5.
Mm-hmm. So it's a range.
A range, yeah.
Okay. Thank you.
So any number from 0 to 5 should be fine. If you take x equal to 6, no. Why x not equal to 6 is not good? Because if x equal to 6, it will violate x smaller equal to 5, this condition. X must be satisfied these 3 conditions at the same time. These 3.
That makes sense. Yeah.
Okay?
Thank you.
You're welcome. Thank you for asking.
Hi there. I
Hello.
just had a very basic question. This was brought up in the last break, well, right before. Someone was asking how simple he wants to go with some of the equations for answers. Say like a homework assignment, we do something that is close to simplest form but we like miss the simplest form, that's fine, right? As long as we like show our steps to how we got it correct again.
As long as you have 90% correct, we consider you not correct.
Okay.
Don't worry too much. But if you have just 70% correct, we will deduct mark.
Okay.
Okay.
Very perfect. Thanks.
Yeah. All right, shall we continue? Okay, welcome back. Any questions before we continue? Okay, vertical line test. Remember the definition of function. 1 point from A will produce just 1 point from B. But in this diagram, when we have x equal to 9, that is 1 point, I produced 2 points. One is 9, one is 3, the other is -3. So this is not a function, not a function, okay? This graph represent a function? The answer is yes, because 1 point of x can only produce 1 y. You pick any point. If you have 1 x, the result is 1 y, okay? And this one is a function. Anyone, is this one a function? No, because 1x, I produce 3y, y1, y2, y3. 1x, I produced 3y. This is not a function. Okay. And this one here, is this a function? This one here a function? Yes. 1x produce 1y. Pick any x, it is just 1y. So this is a function. Is this a function? The answer is yes, because 1x produce 1y. Although there is a gap between here, but this is still a function, although there is a gap. Okay, so section 2, algebra of functions. Okay. So this one, if we have two functions, f and g, the sum of these two functions is here. So f plus g bracket x equal to fx plus gx. And the difference, the product, and the quotient. So those are just the notation. Just the notation. Now let's take an example. If I have fx square root of x plus 1, I have gx 2x plus 1, found the sum s, found the difference d, found the product p, found the quotient q of f and g. So first, we need to know what is the domain of f. The domain of the function is all the x, that is the value. So because this f is the square root, we know anything has a square root, this part must be greater or equal to 0. You cannot have -2, -4 in the set of, we are talking about R means real number. Okay, beyond real number, we do allow -2, -4, but that is above our coverage. Our coverage, we restricted in the real number. In real number, we do not allow -2 square root, -4 square root. Okay, we do not allow this. So anything square root, we need to greater or equal to 0. So if x plus 1 greater or equal to 0, x greater or equal to -1, so the domain is -1 to infinity for f. And now the domain of the g is 2x plus 1. X can take any number for g. Okay. And the common part for A, for set A and set B, this means intersection, okay, is -1 to infinity. So this is the first step. We need to take care of the domain, which x is allowed. So it is from -1 to infinity. And then we solve for sum. So sum of, what is the sum? Sum, it is just fx plus gx, that is the sum. So you just add them together. This is the result of S, sum of f and g. And difference d means you do the subtraction fx minus gx. So x plus 1 minus 2x plus 1. If you want, you can simplify. It is minus 2x minus 1. Okay. And product P means fx times gx, means square root x plus 1 times 2x plus 1. This is the final result. You cannot simplify. And quotient Q, quotient Q equal to fx over gx equals square root of x plus 1 over 2x plus 1. Okay. Any questions? Yes.
Can you simplify the quotient further, or is it just getting complicated?
I'm sorry, can you repeat?
Yes, can you simplify the quotients further?
Thank you. The question was, can you simplify the quotient? You can't. This is the simplest form. Because the square root is on the top. If the square root is on the bottom, you must simplify. Usually we do not allow square root on the bottom. Okay? But our square root is on the top. Thank you for asking. Any other questions? Okay, composition of functions. Composition of functions. This one a little bit complicated, so I try to go slow. The definition of composition function, little bit abstract. Okay, so I'd rather go to the example, then we go back to this definition. So go example first. You have two functions. One is fx, another is gx. Okay. So now you are asked for the composite function of, so what do we read? This one read as G circle F. Sometimes it's also called a composite function. Okay, so how do you read this? So G circle F. Okay, what does it mean G circle F means? I try to go slow. You take a function G as a function. In G function, when you say X in G, you plug it in F. Okay, I'll try to go there. This is G. Do you agree this is G? In G, do you say X? Yes, you say this X. When you say this X, you plug in Fx in this X. That is G circle F. I will do it slowly. G circle F means in function G, when you say X, you plug in F. Is that right? That is the composite function. When you say X, plug in Fx. And then simplify this one. But this one is already simplified. You cannot further simplify. Okay? Now let's look at the other one. F circle G. F circle G means the function is F. The function is F. In this F, do you say X in F? Of course, you say this X. When you say X in F, instead of this X, you plug in GX. Okay, so let's do it. So focus on function F. I have X squared minus 1. When you say this X, plug in the X with G. This is G squared minus 1. Is that okay with everyone? Okay. And you can simplify this one. Opening this bracket, it becomes X plus 2 square root F plus 1 minus 1. So the result, final result is this one. And you need to practice more to get comfortable with this composite function. Okay. Questions? All right. So section 3, functions and the mathematical models. Those are the examples of functions. So to create mathematical model, you follow this diagram. You can easily read. Polynomial functions is in this format, degree of n, and each letter, each an minus 1 has a name coefficients. The particular polynomial function is degree equal to 1. This is actually a straight line. In this straight line, we call this A1 is the slope, A0 is the intercept. Straight line function. Okay. Example. Overdraft fees have become important piece of bank's total fee income. The following table gives the bank revenue from overdraft fees from year 2004 to year 2009. So this represents 2004, 2005, 2006, 2007, 2008, 2009. Okay. So based on this one, you can have this table. This table is the same as this one. So what is the question here? The question asks you to produce a straight line, represent. So this is t, and this is ft. Or you can consider this is x, this is fx, same thing, okay? So how do we do it? You can do it in Excel. So I'm going to do it in Excel here. So I will quickly type in the number. I have actually the number from PowerPoint. Since there aren't many numbers, I will just directly type them in, okay? So from 0, 1, 2, until 5. So you type in those numbers. And then 27.5, 29, 31, 34, 36, 38. So those are the points. The question is based on this 6 data, write down an equation. Write down an equation. So how do I write down equation? You select this data range first, then go to Insert, Chart, All Charts, Scatter Plot. So pick this one here, and click OK. So after you click OK button, you go to the chart elements. Click this button, chart elements, and then check out the trend line. After that, you go to this right angle button, click More Options. More options. Toward the end, scroll down, check out Display Equation on Chart. Display Equation on Chart, so that see you have equation. Okay. I'll try to make this equation bigger. See, this is the equation, y equal to 2.18x plus 27. Okay, this is the equation based on the data. Okay. And based on this equation, what is the slope? The slope is 2.1857. What is the intercept? 27.119. What is the meaning of the slope? 2.1857. The meaning of the slope is that when you change x by 1 unit, y change by 2.1857 units. And what is the meaning of the intercept? 27.119. The interpretation is When x equal to 0, y equal to 27.119. So make sure you know how to interpret slope and intercept. All right, any questions? So this is this one, but we use t, and t is our x in Excel, okay? And based on this equation, question B, you can make a forecast. When t equal to 6, so you plug in x equal to 6 here, you get y, okay? So 2.1857 times 6 plus 27.119, you get y. You can make prediction based on this model. Okay, any questions? And this is the Excel I did, okay? Okay, that is the straight line. When polynomial function has a degree of 1, you have straight line. When polynomial function has a degree of 2, you have a quadratic function, okay, quadratic function. So the graph of the quadratic function either open upwards or open downwards. And how do I know it is upwards or downwards? Depending on the A, coefficient A, this A. If the coefficient, if this A greater than 0, you get upward. If A smaller than 0, you get downward. Okay. So the example of this upward could be y equal to 2x squared plus 3x plus 1, just for example. And the example of this downward could be y equal to negative 3x squared plus 4x plus 5, just for example. So depending on this is smaller than 0, upwards. This one greater than 0 too. Okay. Okay, rational and power functions. Rational function is just a quotient of two polynomials. And this is an example of a rational function. It is a quotient of two polynomials. Okay. The power function is in this format, fx equal to x raised to power r. Some economic models. In economic, we have a supply curve, we have a demand curve. The demand curve always is downwarding, supply upwarding. And the intersection point we call equilibrium price. And this diagram, X represents the quantity, Y, we don't use Y, we use P, represent the price. P represent price. It is actually our Y, mathematically. Okay, example. The demand function of blue, the demand function is dx, is this one. When you see the negative sign in front of x squared, means this, something like this, downwarding, okay? This is negative. And then supply function, you have this is positive, means maybe something like this, positive. And what is the question here? Find the equilibrium quantity and the price. That is the question. Okay. So to solve for this question, we first sketch. We can sketch the demand and supply function. So the demand is a curve down, downwarding. This is demand. Supply is up. So we are asked to find this point. So this is X, this is price P. So what is this point? That is the question. Okay? And we know if demand equal to supply, so we set these two equations equal. So solution, negative 2.205 x squared minus 0.5 x plus 60 equal to supply function 0.02 x squared plus 0.6 x plus 20. Okay, this is the idea. Solve this equation, and this is the quadratic function. You can use quadratic formula to get solution. But first of all, you want to solve demand equal to supply, and then simplify this equation, you get this one. Okay, and this is the same as this one, and this is the standard polynomial quadratic function. Okay, and continue simplify, divided by 5, you get this one, and then you factor this one, or you can use the formula. Now let's practice the formula. The formula for ax squared plus bx plus c equal to 0, x equal to this is the formula. In this case, A equal to 9, B equal to 220, C equal to negative 8,000. So plug in ABC in this formula, ABC, you will get two solutions. One is x equal to negative 400 over 9. The other is x equal to 20. Since x represents number of quantity, so this one is rejected. We only take x equal to 20. Okay, so the equilibrium is x equal to 20. The unit is 1,000. Once you get x equal to 20, you plug in this x in any function, you get a price. Okay. So this is the diagram. This is the demand function. This one is the supply function. The equilibrium is here, x equal to 20, y equal to 40. Any questions? Yes.
Can you still back it up for the
Other questions? All right. Constructing mathematical model. This one is interesting to build a fence. Okay. The owner of Rancho Los Feliz has 3,000 yards of fencing to enclose a rectangular piece of grazing land along the straight portion of a river. Fencing is not required along the river. Let X denote the width of the rectangle. You have a rectangular here. X is the width of the rectangle. Found the function f in variable x given the area of grazing land if she uses all of the fencing. So what we are asked to do, found the function of f. Okay, so if this is x, let's say the x represents the width. So we use y represent the length. So the area is x times y. Do you see that? Area equal to x times y. Area. Okay. And then the length, you have 3,000. So this plus this equal to 3,000. So x plus y plus x must equal to 3,000. Do you see that? It is given here, 3,000. And from here, we can, this is the same as 2x plus y equal to 3,000. And then we solve for y. Y is 3,000 minus 2x. So the area is x times y is x times 3,000 minus 2x. So this is the area. Any questions? So maybe I'll write the area equal to x plus y. And then area equal to x plus y equal to 3,000 minus 2x. So the final answer, negative 2x squared plus 3,000x. That is the area. Okay. Questions? Right. Of course, you have to have some boundaries, okay? So this greater than 0, x, y greater than 0, okay? All right, so that concludes our lecture for today. In summary, we reviewed chapter 1 and we did 3 sessions of chapter 2. Next class, we'll do session 5 of chapter 2. Thank you so much. Have a great week. I will see you next Monday. Good night. Take care of yourself, both physically and mentally, okay? Take care of yourself, both physically and mentally, everybody.
So there's no homework or anything we have to complete in the next class?
Not homework for week 1, okay?